Assalamu alaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NIVS Home School. I am Sabreena Haque, Assistant Teacher of Science, National Ideal English Version School, Day Shift. Dear students, today I am going to taking a chemistry class for class 9 student on the based on chapter 3, and this is our last part of the chapter, and with this we will discuss the exercise creative questions answer. Come to our today's topic. Dear students, today we will learn about atomic mass or relative atomic mass. We have already learned about the atomic mass of the atom when we add the neutron number and proton number. That time we will get the mass number of the atom, but mass number of the atom and relative atomic mass is not the same. If this is same, we have already seen the atomic mass of copper is 63.5 and the atomic mass of the chlorine is 35.5. It can be possible if that is the total mass number and the relative atomic mass will be same. Then what is relative atomic mass? The relative atomic mass is the mass by we can find out the relative atomic mass with the help of 3 scales. There is 3 scales. That one is hydrogen scale, another is oxygen scale, and another is carbon scale. Then in your book there is only written about the carbon scale. Here they give 2 atomic mass, that is fluorine's fluorine mass of an atom is 3.16 multiplied with 10 to the power minus 23 gram, and the mass of aluminium is 4.482 multiplied with 10 to the power minus 23 gram. It is really hard to use such small masses. This is why 1/12 of carbon 12 isotope is taken as the unit, and then the atomic mass of other atom are determined relative to do that. This is the formula to how we will find out the relative atomic mass. The mass of an atom of the element that divided by 1/12 of mass of a carbon 12 isotope. Carbon has 3 isotopes, only carbon 12 isotopes is using here for finding the relative atomic mass, and the carbon 12 isotopes mass is 1.66 multiplied with 10 to the power minus 24 gram. If we know the actual mass of an atom, we can determine the relative atomic mass. We have to divide the total real mass of an atom by 1.66 multiplied with 10 to the power minus 24 gram to get the relative atomic mass. The real mass of aluminium is 4.482 multiplied with 10 to the power minus 23 gram. So relative atomic mass of atom is 4.482 multiplied with 10 to the power minus 23 gram divided by 1.66 multiplied with 10 to the power minus 24 gram. Then if we divide by using the scientific calculator, we will get the relative atomic mass of an aluminium is 27. Then the relative atomic mass is a ratio of 2 masses. It does not have any unit. So what we can understand by this 27? By this 27 we can understand the aluminium, one atom of aluminium is 27 times heavier than the 1/12 of mass of a carbon 12 isotope. This is the meaning of relative atomic mass. Now come to determine the average relative mass of an atom from percentage of isotope. Most of the elements in nature have more than 1 isotopes. We calculate the average relative mass those elements having more than 1 isotopes from their percentage and availability in the nature. The steps in the calculation are: first one, multiply the mass number of all isotopes of that element with the percentage of natural availability of those isotopes. Second step, get the summation of all the result of step 1. Third step, divide the total step 2 by 100, thus will give the average relative mass of that element. Suppose an element A has 2 isotopes. if the mass number of the natural availability of one isotope, those isotopes are P and M respectively, while the same number of Q and N, then the average relative atomic mass that elements will be P into M plus Q into N divided by 100. We can easily understand by finding this relative atomic mass by using the chlorines 35 and chlorine 37 isotopes. The chlorine 35 isotopes are 75% available in the nature and chlorine 37 isotopes 25% available in the nature. So by following this rule, we can find out the relative atomic mass of chlorine. 35 into 75, this 35 multiplied by 75 plus 37 multiplied 25 divided by 100, and you will get this one 35.5 is the relative atomic mass of the chlorine. By using this, we can easily find out the relative atomic mass of an atom. In the periodic table also, you will see the average relative atomic mass is shown as 35.5. The periodic table displays the average relative atomic mass. For example, if there are two naturally available isotopes of an element, and we can calculate the percentage of those isotopes available in the nature from the average relative atomic mass. That means if we have the percentage of that isotope, we can find out the relative atomic mass, and if we have the relative atomic mass, that time we also can find out the percentage that are available in the nature. Then suppose in the nature copper 63 and copper 65 available X% and 100 minus X%. Then available relative atomic mass of copper is equal to average relative atomic mass of copper is equal to X into 63 plus X minus 100 minus X into 65 divided by 100 is equal to, we know copper's relative atomic mass is equal to 63.5. Then we will get the value of X by using the algebraic mathematical system 75.5. Naturally available percentage of copper 63 is 75%, and if we subtract this 75%, we will get the copper 63 is available 25%. Now getting the relative molecular mass from the relative atomic mass, we get the relative molecular mass of an atom by taking the summation of multiplied value of relative atomic mass of atoms with their respective number of atom generally. Relative atomic mass is considered as atom mass and relative molecular mass as molecular mass. The relative atomic mass of hydrogen in hydrogen molecule is 1 and it has 2 atoms, so the relative molecular mass of hydrogen molecule is 1 into 2, that means 2. Similarly, we can find out the sulfuric acid molecules. The relative atomic mass hydrogen is 1 and the number of atom is 2. Relative atomic mass sulfur of 32, the number of atom is 1. The relative atomic mass is oxygen is 16, the number of atom is 4. Then by following this formula and following this process, we can find out the relative atomic mass of sulfuric acid is 98. Like this way, we can easily find out the oxygen relative mass or molecular mass also. 1, hydrogen's atomic mass is 1, then there is 2 atom of hydrogen, and oxygen relative atomic mass is 16 and there is only 1 atom, then it will be 18. Like this way, we can easily find out the relative molecular mass of an atom if we have we know the relative atomic mass of required elements. Now come to the radioactive isotopes and their uses. We have already learned about the isotopes in this chapter. There are some isotopes of the nucleus which spontaneously synthesize themselves and emit alpha, beta and gamma rays, and they are called radioactive isotopes. And so far scientists have gathered information more than 3000 isotopes. Some of them are natural and some are laboratory made. And Controlled use of radioactive isotopes has made many and impossibly possible. Presently, such isotopes are used in medical science, agriculture, preservation of food and seeds, electrical generation, etc. Now come to medical science use. Medical science employs radioactive isotopes for various purposes. Diagnose. We can take pictures of the effective area by using radioactive isotope. Technetium 99 is injected inside the body. In this system, when it is gathered, a particular isotope at a certain place inside the body, the isotope emits gamma rays. The gamma ray identification camera from outside can take the photo of that spot of the body. The lifetime of the isotope is 6 hours. Since it loses the radioactivity within a short time, it is safe. Now come to treating disease. And radioactive isotopes was first used to cure thyroid cancer. The patient is made to drink solution of iodine isotopes, which has atomic number 131. These isotopes reaches the thyroid and emits beta rays which destroy the affected cell. Iridium isotopes used to treat brain cancer. Cobalt-60 isotope is used to diagnose the treat tumors, and the gamma rays emits from the isotope destroy the cancer affected tissue. And phosphorus-32 isotopes is used to treatment of leukemia. Leukemia also a kind of blood cancer. Now come to agriculture sector, and in agriculture sector, nitrogen and radioactive nitrogen and phosphorus isotopes are used to find out how much nitrogen and phosphorus present in the soil. Plant and absorb radioactive nitrogen and phosphorus via its roots, which is then transferred to the different part of its body. The Geiger-Müller counters helps to identify the presence of these isotopes and helps to determine the presence of two elements in the soil that we can determine the remedy to. Now, getting harmful insects by using the radioactive isotopes, we also can kill the harmful insect. Now, development of crop, radioactive isotopes also play a significant role to developing hybrid varieties by generating changes in the original crops. Now come to generation of electricity. A huge amount of heat is found in fusion reaction or by breaking some atoms into smaller atoms. Driving this heat energy through generators, we can produce electricity. We call such power plants nuclear power plant. And the government of Bangladesh is going to establish a nuclear power plant in Rupur, Pabna, and it is hoped that the power plant will be able to produce 2400 megawatt electricity. This is the picture of Rupur nuclear power plant. Now come to impact of radioactive isotopes. It is true that radioactive isotopes are there for a good number of benefit, but at the same time they have the potential to harm too. The alpha, beta and gamma rays emitted from such isotopes can bring about genetic changes to the cell which may cause cancer. The atom bomb used in Hiroshima Nagasaki of Japan during World War II killed lakhs of people, and the Chernobyl accident in 1986 in Russia has killed numerous people and has done harm to the adjacent environment. Now we will solve the exercises of MCQ. First, Z is an element with 111 proton and mass number is 252, which is the most appropriate expression of this. We know the mass number will stay on the left upper side and the atomic number will stay in the left lower side. So, the D will be correct answer. Now, come to the next question. What is the relative atomic mass of the element X? And here X is just a symbol, is not the element. Here X, isotopes, there 144, the percentage of availability is 75%, and isotopes 154, then it is 75. By applying the formula of this, by applying the formula of this, we can easily find out the relative atomic mass. It will be 152. It will be 152. Now come to the question number 3. If the real mass of an element is 4.482 multiplied with 10 to the power minus 23, 4.482 multiplied with 10 to the power minus 23. For finding the relative atomic mass, we have to divide it 1.66 multiplied with 10 to the power minus 24. Then we will get it 27. And come to the next one. The formula of aluminum, there is 27 and 13, and aluminum shows that the element has proton number 13, it is correct. Mass number 27, it is also correct. The electron number 10, it is incorrect. So the answer will be 1 and 2. The question number 5, the atomic number of potassium is 19. Atomic number of potassium is 19. How many energy sublevel are the sodium cell? Then there is 3 energy sublevel in the nitrogen shell. Nitrogen shell, there is 3 atomic sublevel, because there is 2 orbital. Orbit, and in the first orbit there is 1s, in the second orbit there is 2s and 2p. That means in total 3 suborbital. And in the scandium, atomic number of scandium is 21, which one is correct electronic configuration, dear student. Then it will be the correct 1s2, 2s2, 2p6, 3s2, 3p6, 3d1 and 4s2. Now come to the creative question of exercise. Farid, a class 9 student, drew a following picture as he was asked to draw an atomic model. Question number A is what is atomic number. Question B is the nuclear number is 64, mass number is 64 and atomic number is 23 of X, and Y is mass number is 64 and atomic number is 33. The atom are the same but the differ in the number of nucleons. Explains. The question number C is the picture drawn by Farid refer to the limitation of atomic model. Now question D is draw the picture of shows that an atom will not be stable. Then we have to give the answer. Question number A, what is atomic number? The number of proton in the nucleus of an atom of an element is called the atomic number of that element. Now come to question B. X 64 and 23 and Y 64 30 have atomic number of protons, same atomic number, have same atomic number of 23 and 20 sorry, it will be incorrect. Same mass number but atomic number is separate respectively, but mass number is 64 and 64 respectively. So the number of neutron of the mass number A is atomic number Z, then it is the A minus atomic number Z, then mass number of X is 35 and mass number of Y is 34. As the atomic number of proton are different in the elements, so the number of neutron will be different, even though the number of nucleon are the same. It will be is. Come to the question answer C. The model drawn by Farid supports Rutherford's atomic model. The information obtained from the model given by Rutherford gives a clear concept about the atomic structure. First one, in the center of the atom there is a positively charged massive substance. This massive substance is called the center of the nucleus of the atom. Compared to the whole volume of the atom is volume of nucleus is negligible. It is processed almost the whole mass of the all positive charge. Question number point 2, atom are electrically neutral. So nucleus is surrounded by a number of negatively charged electron equal to the number of positively charged proton of the nucleus. Last one, the electrons always moves round the nucleus as the planets revolves round the sun in the solar system. The centripetal force of the electrostatic force between the positive nucleus and the negative electron is equal to the centrifugal force of the moving electrons. Dear student, question number D is this drawn picture shown that an atom will not be stable. We have to give the explanation why. We know the limitation of Rutherford atomic model. There is said that that model are compared to the solar system, but the planets are charged neutral, but here electron are charged and also nucleus are charged. According to the Maxwell theory, this is not possible. Analyzing the model drawn in the stem, it can be seen the electrons revolves in a spiral path. This is moves in a spiral path and reaches to the center. It comes to the center, and it is the unstable model of atom. It is according to Maxwell electromagnetic theory of radiation, any charged particles if moves in a circular way always emits radiation, and its radius of movement will become smaller gradually and ultimately reach the center. So according to Rutherford's atomic model, the atom will be unstable. There will be logical opinion about the stability of the model drawn. Now come to the question number 2. There is element A, that cobalt 60, element B phosphorus 32, and the compound C H2SO4. That is the stem of the question. First question is what is symbol. Second question, when the spectra created in an atom discussed. Question C, find the relative atomic mass of compound C. And question D, the isotopes of A and B play significant role in our lives. Explain. Question answer A is abbreviated form of English or Latin name of an element is called its symbol. Question answer of B is when an electron moves around its principal energy level, it does not absorb or emit any energy. However, it absorbs energy when it moves from a lower energy to higher energy level. The same way, an electron emits energy when it moves from higher to lower energy level. The light emitted when an electron moves from one energy level to another creates an atomic spectra when it goes through a prism. Now, question number C was find out the relative atomic mass of the compound C. Dear students, we have already learned this here. This is the question answer C. 2C. You have to follow your textbook page number 53 and you have to write the question answer of C. Now come to question answer D. The isotopes of A and B play significant role in our lives. Explain. Their isotopes cobalt 60 and isotopes phosphorus 32. We have already discussed in our this class how we will use the cobalt 60 and phosphorus 32 in our lives. Come to the answer. A and B elements cobalt 60 and phosphorus 32 respectively, which are radioactive isotopes of cobalt and phosphorus. Atoms of same elements with equal number of protons but different number of neutrons and mass are called isotopes. There are some isotopes, the nucleus of which spontaneously synthesize themselves and emits alpha, beta and gamma rays. They are called radioactive isotopes. Radioactive isotopes are used in many sectors. Treating disease. Cobalt 60 isotopes used to diagnose and treat tumors. The gamma rays emitted from these isotopes destroy the cancer affected cell and tissues. Phosphorus 32 isotopes is used to treatment of leukemia. Leukemia is one kind of blood cancer. Nutrition of crop. Significant fertilizer are required for the nutrition of the crop. The quality of fertilizer is an important issue. Excess fertilizer costs more than necessary and it is also harmful for environment. Again, less than necessary fertilizer won't be any help. Radioactive isotopes helps to determine amount of phosphorus present in the soil. Plants absorb radioactive phosphorus via its roots when which is then transferred to different parts of its body. Gregor molar counters helps to identify the presence of those isotopes and help to determine the presence of phosphorus in soil. Then the remedy can determine too. Dear students, this is your homework number 10. You have to do CQ1's D's answer and CQ2's C's answer as your homework. Dear students, I have finished my today's topic. Hope you have understood. If you feel any problem, you can contact with me. Stay safe, stay good. Thank you. Allah Hafiz.